Good evening, everyone. Welcome to the live interaction session for our course Biomechanics by Professor Varadhan, Department of Applied Mechanics and Biomedical Engineering, IIT Madras. I am your TA, Manjunathan, Research Scholar from the Department of Applied Mechanics and Biomedical Engineering, IIT Madras. Today we will be discussing the contents from the videos that posted for the week 10 in our course. I hope you all have watched the videos. If you haven't watched the videos, please go back and watch the videos so that you'll be better informed about the contents of the course and can uh, test your knowledge better. And these interaction sections are provided to make best uh, of the course understanding. So if you haven't watched the videos, please watch the videos first, then try to attempt the questions. So let's start our session. So in week 10, so in week 10, you might have watched the videos. In week 10, the course is about something called enslavement. So we have observed this uh, feature of enslavement in many of our organs, especially in hands and fingers, but uh, we may not have looked into it in a deeper level. But this part of the course is uh, explaining about the enslavement effects of the fingers and also going forward to discuss two state-of-art research papers from Satrowski and Niranjan Chakravarti that have been who were the researchers who studied well about the enslavement effects from different perspectives and have found some significant results from these. So I hope you have watched the videos. So in first research paper, so how the enslaving effects is interacting with the finger force production that is being discussed. And in second research paper is about what is the effect of wrist posture. Does the wrist have any role in the enslavement effect or the interdependence of the fingers? So two key that is the two key uh, facts that is being investigated in these two papers. So these papers are some in the forefront of some finger enslavement studies. You can check these papers also if you want to know much more about it. So I will be discussing the questions and the questions that may be coming to the your final exams from these kind of these week's videos in our today's session. So let's move on to our first question. First question is what does force enslavement refer to? What does the word force enslavement refer to? Options are intended force generated in instructed fingers, unintended force generated in instructed fingers, unintended force generated in non-instructed fingers, intended force generated in non-instructed fingers. So what does force enslavement refers to? Is it the generation of intended force in instructed fingers? Is it unintended force generated in instructed finger? Option C, unintended force generated in non-instructed fingers. Option D, intended force generated in non-instructed fingers. So, which among the following best suits for the term force enslavement? You can inbox your answers. Please do respond. The concept of enslavement we have mentioned in last week session also, if you remember. So, what does the word force enslavement refers to? You can inbox your answers. So here, the instructed fingers mean the fingers which we are giving some task to. So we want to move our fingers, or we want to lift something. We have to man move or maneuver our fingers. So we will be when we are pointing towards somebody, we will be pointing with the index finger. So that is the uh, prominent finger there. So like the instructed finger is the finger we want to move. Uh, so I hope that makes it more clearer. Okay, so the answer here is option C, that is unintended force in non-instructed fingers. So option A is saying intended force in instructed fingers. So intended force in instructed fingers is the best scenario we are looking at. We want the maximum force, or the intended force, not the maximum. The force we want to be there is reaching or happening in the finger we want. So option B is not an uh, desired condition. It is saying unintended force in instructed finger. So even though the finger is correct, it is creating some unintended force. So that is not a desired result. Uh, and option D is intended force in non-instructed fingers. So this formulation itself is wrong. So our answer is option C, unintended force in non-instructed fingers. So some unintended force is unintended means unwanted or uh, undesired force is happening in the some other fingers than the desired finger. So that's the meaning for sorry that is what the force enslavement word refers to. Answer is option C. Enslavement is the unintended force production in non-task fingers. Next question. What is finger interdependence? Option A, involuntary movements in non-instructed fingers when another finger moves. Option B, the ability of fingers to move independently without any external influence. Option C, a specific condition that affects only thumb and the little finger. Option D, none of the above. What is finger interdependence? Is it the involuntary movements in non-instructed fingers when another finger moves, or is it option B, the ability of the fingers to move independently without any external influence. Option C, a specific condition that affects only the thumb and the little finger. Option D, none of the above. You can inbox your answers. Answer is option A, that is involuntary movements in non-instructed fingers. Same as the finger enslavement. That is the involuntary movements in non-instructed fingers when another fingers move. That is, it should be when. So that should be the complete response. Finger interdependence is the involuntary movements in non-instructed fingers when another finger moves. This is the involuntary motion of uninstructed fingers. Next question. Which of the following mechanisms is associated with finger interdependence? Options are option A, mechanical coupling, option B, neural mechanisms, option C, both A and B, option D, neither of A and B. Which of the following mechanism is associated with finger interdependence? Is it option A, mechanical coupling, or is it option B, neural mechanisms, or is it both A and B, or neither of them? You can inbox your answers. Our answer is option C, that the finger independence, the mechanisms that is behind the interdependence of the fingers are both mechanical coupling and neural mechanisms. So these both together are both has some degrees of influence in the finger interdependence. So our answer is option C, both the options A and option B. Our answer is option C, both tendon linkage, that's the mechanical coupling, and the neural control, the very neural control, both these contribute to the finger interdependence. Next question. So, in the two studies discussed in the videos of week 10, one study is studying about the effect of wrist postures in uh, finger interdependence or force generated in fingers. So, what were the or which of the following were the ranges of angles of wrist postures tested in that study? So, what were the wrist postures tested in the study? Options are option A, 0 degree, that is neutral, then 30-degree extension, and followed by 30-degree flexion. Option B, 0-degree neutral, 45-degree extension, 45-degree flexion. Option C, 10-degree neutral, 20-degree extension, 20-degree flexion. Option D, 0-degree, 25-degree extension, 25-degree flexion. So, which among the following is the set of rest postures tested in the study that is being discussed in our week 10 lectures? The answer is option A, 0-degree neutral, 30-degree extension, 30-degree flexion. So, the standard external postures included in the study were 0 and plus and minus 30 degrees. That were the rest postures studied in our study. Next question. What indices were used to quantify finger interdependence? Options are option A, enslavement matrix, individuation index, stationarity index. Option B, flexibility index, mobility index, dependency matrix. Option C, strength index, dexterity matrix, coordination index. Option D, none of the above. Which of the following is the indices used to quantify finger interdependence? Options are option A, enslavement matrix, individuation index, stationarity index. Option B, flexibility index, mobility index, dependency matrix. Option C, strength index, dexterity matrix, coordination index. Option D, none of the above. Yes, the answer is correct. Option A, that is the enslavement matrix, individuation index, and stationarity index were the indices used to quantify the finger interdependence. Next question. Which fingers were instructed for movement in the study? Which fingers were instructed to movement in the study? Options are option A, index finger, middle finger, ring finger, and little finger. Option B, thumb, index, and middle. Option C, middle, ring, and little. Option D, index and thumb. So, which were the fingers instructed for movement in the study? Options are option A, index, middle, ring, and little. Option B, thumb, index, and middle. Option C, middle, ring, and little. Option D, index and thumb. Answer is option A, index, middle, ring and little. Option A, all four fingers except thumb. Next question. How was the finger movement recorded? Or finger movement was recorded using which of the following? Options are option A, electromagnetic sensors. Option B, visual observation. Option C, pressure sensors. Option D, by manual measurements with a ruler. So, how was the finger movements recorded? Options are option A, using electromagnetic tracking sensors. Option B, through visual observation. Option C, using pressure sensors on the fingertips. Option D, by manual measurements with a ruler. Our answer is option A, that is electromagnetic tracking sensors. Electromagnetic tracking sensors were used for recording the finger movements. So, electromagnetic tracking sensors provide precise motion tracking in kinematics. That's right. Our answer is option A. Next question. What was the primary finding regarding individuation and stationarity indices across wrist postures? What was the primary findings on indices across wrist postures? Options are option A, significant variation. Option B, mostly equivalent. Option C, only individuation varied. Option D, only stationarity varied. So here indices are individuation and stationarity. So what was the primary finding regarding individuation and stationarity indices across rest postures? Options are option A, they significantly varied across rest postures. Option B, they were mostly equivalent across rest postures. Option C, only the individuation index varied. Option D, only the stationarity index varied significantly. Answer is option B. So, in the study for the effect of risk postures on indices, they, they were mostly equivalent. The For different risk postures, the indices were equivalent, or the indices largely remained unchanged. Our answer is option B. Next question. What does an enslavement index of 1 indicate? What does an enslavement index of 1 indicate? Options are option A, maximum passive movement. Option B, passive finger stationarity. Option C, full independence. Option D, no movement. What does an equivalent index of what does an enslavement index of 1 indicate? Options are the passive finger moved maximally with active finger. Option B, passive finger stays stationary during active finger movement. Option C, the active finger moved independently of passive fingers. Option D, passive finger did not move at all. The answer is option A. So enslavement index of 1 meaning full coupling or uh, full enslavement. So the passive finger moved maximally with the active finger. That is what enslavement index of 1 indicates. So here value of 1 equals to full coupling. Next question. The effect of movement direction on enslavement. What is the effect of movement direction on enslavement? Options are option A, significant. Option B, not affected. Option C, only extension. Option D, only flexion. So this is from the study of Chakrabavi et al. So from the study of or results of Chakrabavi et al, the causes of finger enslavement are options are sorry. However, the enslavement indices affected by the direction of active finger movement. So what is the effect of movement direction on enslavement? Significantly affected, not affected, only affected during extension movements. Option D, only affected during flexion movements. Yes, correct answer. Option B, it's not affected. The movement direction was not influencing the enslavement. Direction did not significantly influence the enslavement. The answer is option B. Next question. The most independent finger from this found from the study is what? Options are option A, index finger, option B, middle finger, option C, ring finger, option D, little finger. So, which finger was found to be the most independent based on the individuation index? Based on individuation index, which among the following was found to be the most independent finger? Is it option A, index finger, or is it option B, middle finger, or is it option C, ring finger, or is it option D, little finger? is correct answer. Option A. Index finger showed the maximum uh, individuation or independence from the study. Option A. Index finger shows highest individuation. Next question. Effect of wrist posture on stationarity index. Option A. Significant. Option B. No changes. Option B. Only during extension. Option D. Only during flexion. So what was the effect of wrist posture on stationarity index? Options are: option A, significant changes were observed. Option B, no changes were observed. Option C, only significant in extension wrist posture. Option D, only significant in the flexion wrist posture. Yes, correct answer. The stationarity index remain unchanged during the wrist posture. Answer is answer B or option B. The stationarity index remained stable for the different wrist postures. Next question. This, I think we have discussed earlier also. What is the causes of finger enslavement from the Chakrabavi et al. Study? Options are purely mechanical. Option B, primarily neural causes. Option B, both equal chances. Option D, neither neural or mechanical causes. Answer is option C, correct answer. Option C is the correct answer. Both neural and mechanical factors are there, but neural factors dominate sometimes. Next question. Muscles contributing via long tendons, or which muscles were implicated in finger interdependence due to their long tendons? Options are: option A, intrinsic muscles in the hand. Option B, extrinsic. Option C, both A and B. Option D, neither A nor B. Question is, which muscles were implicated in finger interdependence due to their long tendons? Options are: option A, intrinsic muscles of the hand. Option B, extrinsic muscles of the forearm. Option C, both A and B. Option D, neither A nor B. Answer is option B, that is extrinsic muscles. Option B, extrinsic muscles of the forearm. Extrinsic muscles of the forearm contributes due to the long tendons. Extrinsic muscles have a long tendons which causes the coupling, mechanical coupling. So our answer is option B. Next question. Note used for enslavement. What was note used as a method to quantify enslavement in the study? Options are option A, enslavement matrix, option B, flexibility index, option C, individuation index, option D, stationarity index. So, which among the following were not used in the study to quantify the enslavement effects? Options are option A, enslavement matrix, option B, flexibility index, option C, individuation index, option D, stationarity index. The answer is option B, that is flexibility index. So we have not discussed anything about flexibility here. In the previous questions also we are discussing about enslavement matrix, individuation and stationarity. So there were no flexibility index used in the study. So our answer is option B. Answer is option B. Flexibility index is unrelated. Next question. What was the main purpose of the study? Options are option A, effect of wrist posture on indices. Option B, MVC study. Option C, strength testing. Option D, flexibility. So the question is, what was the main purpose of the study? Is it to examine the changes in indices due to systemic changes in the wrist posture? Option B, is it to explore the maximum voluntary contraction of fingers? That is, MVC is maximum voluntary contraction. Is it to explore the maximum voluntary contraction of fingers? Option C, is it to test the strength of finger muscles? Option D, is it to investigate the flexibility of wrist joints? What was the main purpose of the study? So the answer is option A, effect of wrist posture on the systemic uh, effect of wrist posture on the indices. Answer is focus was posture versus, that is wrist posture versus finger independence. Next question. Stationarity index means which among the following? Options are finger remains still when others move. Option B, speed measure, or is it an MVC measure? Option D, is it a measure of statistical significance? Which among the following is the correct description of the word or the term stationarity index. Options are option A, to extent to which a finger remains stationary when other fingers are active. Option B, the measure of how quickly a finger can move. Option C, the index measuring the maximum voluntary contraction. Option D, the statistical significance of movement direction of finger interdependence. So the answer is option A. So stationarity means remain stationary. So stationarity is mean remain stationary. So from that, if you understand the word meaning of stationarity, so the answer becomes very intuitive. That is the ability of the finger to remain stationary. Ability to remain stationary when other fingers are active. Are active. The answer is option A. Stationarity index measures the passive finger stability. In other words, it measures the passive finger stability. Next question. It's also a repetition. The effect of wrist posture on enslavement. Option A, significant changes across all indices. Option B, they did not cause any change in the indices. Option C, only affected the little finger. Option D, only increased the individuation index. II is the individuation index. Yes, the correct answer remain unchanged, or no effect was there uh, on the enslavement for different wrist postures. Answer is option B. The enslavement was unchanged across different wrist postures. Next question. No change suggests dominance of which among the following? Mechanical, neural, psychological, or random? The study found no significant changes in enslavement indices across different wrist postures, suggesting a greater role of which factor in the finger interdependence. The study found that there was no change of wrist posture on finger enslavement. So what does that suggest? So which factor have dominance? Is it option A, mechanical, or is it option B, neural? Is it option C, psychological, or is it option D, random? The answer is option B, that is neural. We have discussed in a previous question also. Neural has an upper hand. Neural factors has an upper hand. So the answer is option B, neural. neural control dominance. Next questions. Muscles studied for enslavement effect. Options are FDP, FDS, intrinsic, option D, EDC. Which were the muscles explored in the study for their contributions to the enslaving effect? We discussed these muscles in previous sessions. Options are option A, FDP, FDS, intrinsic, and EDC. So, if you don't remember the full forms, FDP is flexor, T is for digitorum, P is for profundus. Next one, FDS is flexor, digitorum, S is for superficialis. Uh, Third one is intrinsic muscles itself. Fourth one is short for E for if F is for flexor, then E is for extensor. Extensor, digitorum, communis, MUNIS. So these are the three muscles in the forearm that extends up to digits. Which muscles were explored for their contributions in the study? Here the answer is all of them. It's a multiple uh, choice question. So the questions having multiple answers. So all these muscles were tested or studied for their enslaving effect. The answer is A, B, C, and D. All major finger muscles were analyzed. Next question. Enslaving effects are measured by which among the following? Options are option A, total force, option B, force deficit, option C, force from uninvolved fingers, option D, force difference. Question is, how was the enslaving effect quantitatively measured in the study? Is it by the total force produced by all the fingers, or is it by the force deficit by multi-finger tasks, or is it by the force produced by uninvolved fingers as a percentage of their maximal force in single finger tasks? Option D, or is by the difference in force production between intended and non-intended fingers. Yes, correct answer. Option C, force from uninvolved fingers or by the force produced by the uninvolved fingers as a percentage of the maximum force in the single finger task. Answer is option C. Answer is option C. Next question. The EE across the condition. EE refers to enslavement effect. The EE, how is the EE observed across the conditions? Options are option A, only intrinsic. Option B, varied significantly. Option C, similar across conditions. Option D, absent in intrinsic. Options are EE was only present in tasks including intrinsic muscles. Option B, EE varied across different muscle groups. Option C, it has EE was having similar amplitude across different experimental conditions involving different muscle groups. Option D, EE was absent when intrinsic muscles were primarily used. Read intrinsic as intrinsic muscles. Correct answer. Option C. The enslavement effect magnitude was similar, or the similar amplitude of enslavement effect was observed across different experimental conditions involving different muscle groups. Answer is option C. Next question. What is the average maximum slave force that enslaving fingers could produce? Options are option A, 67.5 percentage, option B, 73.5 percentage, option C, 45 percentage, option D, 28 percentage. What was the average maximum force that slave fingers could produce as a result of the enslaving effect? Options are option A, 67.5 percentage of maximal force. Oh, 65% of the maximal force in a single finger task. Option B, 75% of the maximal force produced in a single finger task. Option C, 45% of the maximal force produced as a single finger task. Option D, 28.9% of the maximal force produced in a single finger task. How many questions? Monarch, the session will extend up to 9. So maximum questions, I will try to cover maximum questions in this up to 9. So our interaction session timing is from 7 to 9. Yes, by the way, the answer is correct, 23D. That's approximately 30% related to the MVC. Next question. The effect of force application point. How did the enslaving effect vary with the positioning of force application points on the fingers? Options are option A, largest at distal, option B, smallest at proximal, option C, increased from distal to proximal, option D, no significant variation. The question is, how did the enslaving effect vary with the positioning of the force application points on the fingers? Options are, the enslavement effect was largest when forces were applied on the distal phalanx. Option B, the E was smallest when the force was applied at the proximal interphalangeal joint. Option C, the enslavement effect increased as the force application point moved from distal to proximal. Option D, the EE or the enslavement effect did not vary significantly with the change in force application points. Okay, I'm going to skip that question. It should be C actually. It should be increased from. Okay, just skip that question. Next question. What is the hypothesis behind the origin of enslavement effects? What is the hypothesis behind the enslavement effects? Options are mechanical only, option B, intrinsic only, option C, temporarily, option D, neural interaction. Or the question is asking the key hypothesis on the origin of enslavement effect. Option A, it is solely due to peripheral mechanical connections between the finger tendons. Option B, it originates exclusive use of intrinsic muscles. Option C, it is a temporary phenomenon that disappears with practice. Option D, it is due to the widespread neural interaction among structures controlling hand muscles. Answer is option D, neural interaction. So majorly it's due to the neural interaction among the structures controlling hand muscles. Option. Next question. Larger enslaving effects were found in which fingers? Options are non-adjacent fingers. Option B, neighboring fingers. Option C, index and middle fingers only. Option D, ring and little fingers only. Which fingers showed larger enslaving effects? Options are option A, non-adjacent. Option B, neighboring. Option C, index and middle fingers only. Option D, ring and little fingers only. Oh my God. So, which fingers show the larger enslaving effects? Option is option B, neighboring fingers. The adjacent fingers sharing tendons showed the maximum enslaving effects. Answer is option B. Next question. What is the role of EDC in the muscle? We have already discussed what is EDC. That is extensor digitorum communis. What is the role of extensor digitorum communis? That is being pointed out by the study. Options are option A, primary contributed, option B, measured deficit, option C, control muscle, it acts as a control muscle, option D, not involved. What was the role of EDC or the extensor digitorum communis found out from the study? Options are option A, it was the primary contributor to the enslaving effect. Option B, it was used to measure the force deficit. Option C, its activity served as a control to ensure subjects followed instructions. Option D, it was not involved in the study. Our answer is option C. There is a EDC act as a control muscle. Answer is option C, that EDC majorly act as control muscles. Option C, used for monitoring or controlling. Next question. What is the EE dependency on muscle activation? What conclusion can be drawn from the enslavement effects dependency on muscle activation? Option is option A, unaffected. Option B, only on FDP or FDS. Option C, only on intrinsic only. Option D, decreases with the extrinsic muscle usage. Question is, what conclusion can be drawn about the enslavement effects or EE's dependency on the muscle activation? Option A, it is unaffected by which muscle groups are activated. Option B, it depends only on the activation of FDP and FDS muscles. Option C, it increases with the exclusive activation of intrinsic muscles. Option D, it decreases when the extrinsic muscles are primarily used. You can inbox your answers. Answer is option A, unaffected. It it is affected unaffected by which muscle groups are activated. Here remains similar across the muscle groups. Answer is option A. Next question. Enslaving is more prominent in which among the following? Options are option A, thumb, option B, index finger, option C, ring and little finger, option D, toes only. Yes, the answer is option C, ring and little fingers. Enslaving is more prominent between or more prominent in ring and little fingers. The stronger interconnections exist in ulnar digits. Next question. Fine motor control requires which among the following? Options are option A, large motor units, option B, low tendon stiffness, option C, small motor units, option D, high friction. Fine motor control triggers which among the following? Options are option A, large motor units, option B, low tendon stiffness, option C, small motor units, option D, high friction. Yes, sir. Answer is option C, small motor units. So here the question is of fine motor control. So fine motor control requires small motor units because small motor units allows precise and graded force. Answer is option C, due to the small uh, small units allow precise graded force. Next question. Synchronization of motor units causes which among the following? Options are option A, smooth movement, option B, tremor or force fluctuation, option C, tendon elongation, option D, cartilage degeneration. What will happen due to the synchronization of motor units? Options are option A, smooth movement, option B, tremor or force fluctuation, option C, tendon elongation, option D, cartilage degeneration. Answer is option B, because simultaneous firing increases force variability. Answer is option B. Simultaneous firing increases force variability. Next question. The mechanical coupling between tendons increases which among the following? Options are independence of movement, option B, coordination of force generation, option C, joint lubrication, option D, neural conduction. Question is mechanical coupling between tendon increases which among the following? Options are option A, independence of movement, option B, coordination of force generation, option C, joint lubrication, option D, neural conduction. Yes, the answer is correct answer is option B, coordination of force generation. So we have seen that it is against the independence of movement. Answer is coordination of force generation because coupling helps or aids in coordinated finger action. So answer is option B, mechanical coupling of tendons aids in coordinated finger action. Next question. During precision grip, enslaving effect is minimized by which among the following? Options are option A, increased friction, option B, selective neural activation, option C, tendon rupture, option D, bone remodeling. During precision grip, E or enslaving effect is minimized by which among the following? The answer is option B, selective neural activation, because the CNS or the central nervous system modulates motor unit recruitment pattern. So selective neural activation helps in precision grips. Next question. The passive force transfer between tendons is highest when? Options are option A, when tendons are slack, option B, when connective tissues are stiff, option C, when muscles are inactive, option D, when temperature is low. The passive force transfer between tendons is highest when option A, tendons are slack, option B, connective tissues are stiff, option C, muscles are inactive, option D, temperature is low. Your answer is option B. Correct answer. Connective tissues are stiff. The passive force transfer between tendons is highest when the connective tissues are stiff, because stiffer linkages transmit more mechanical load. Answer is option B. Next question. The main advantage, the main functional advantage of intertendinous connection is, options are reduced coordination, option B, enhanced load sharing, Option C, increased injury risk. Option D, reduced muscle strength. The main functional advantage of intertendinous connection is option A, reduced coordination. Option B, enhanced dot sharing. Option C, increased injury risk. Option D, reduced muscle strength. This is correct answer. Option B, enhanced load sharing. Correct answer is option B, enhanced load sharing. Load sharing protects the individual tendons. Next question. Increased co-contraction of muscles result in which among the following? Options are option A, reduced joint stability. Option B, increased joint stiffness. Option C, tendon rupture. Option D, lower force transmission. Increased co-contraction of muscles results in which among the following? Options are option A, reduced joint stability. Option B, increased joint stiffness. Option C, tendon rupture. Option D, lower force transmission. Yes, the answer is yes, correct answer. Option B, increased joint stiffness. Because co-contraction, opposing muscles when contract together, the opposite muscles activation stabilizes the joints. Answer is option B. Next question. The rate of force development in muscle tendon unit depends strongly on options are option A, synovial fluid viscosity. Option B, neural activation speed. Option C, cartilage thickness. Option D, ligament length. Options are the question is the rate of force development in muscle tendon unit depends strongly on which among the following? Options are option A, synovial fluid viscosity. Option B, neural activation speed. Option C, cartilage thickness. Option D, ligament length. Answer is option B, neural activation speed. The rate of force development in muscle tendon unit depends strongly on the neural activation speed. The faster the neural drive increases, the rapid the force production happens. Next question. The tendon compliance influence the movement by options are option A, preventing muscle contraction. Option B, modifying timing of force transmission. Option C, eliminating energy storage. Option D, increasing friction. The tendon compliance. How does the tendon compliance influence the movement? Options are option A, preventing muscle contraction. Option B, modifying timing of force transmission. Option C, eliminating energy storage. Option D, increasing friction. Option or correct answer is option B, modifying timing of force transmission. More uh, the more compliant the tendons are, it will the delay the force transfer but enhance the energy storage. Next question. Which factors mostly which factors most strongly explain why adjacent fingers show higher enslaving effect? Options are option A, greater muscle strength. Option B, shared tendinous connections. Option C, larger cortical representation. Option D, increased blood supply. Which factor mostly or strongly explains why adjacent fingers show higher enslaving effects? Options are option A, greater muscle strength. Option B, shared tendinous connections. Option C, larger cortical representation. Option D, increased blood supply. Yes, correct answer. Option B, shared tendinous connection. Shared tendinous connection or the mechanical coupling between the adjacent fingers helps in the enslavement. Next question. A high individuation index indicates which among the following? Options are option A, strong enslaving effect. Option B, high finger independence. Option C, poor motor control. Option D, increased stationarity. Option A, high individuation index indicates which among the following? Options are option A, stronger enslaving effect. Option B, high finger independence. Option C, poor motor control. Option D, increased stationarity. Correct answer, high finger independence. Option B, high finger independence. A high individuation index reflects a better independent control. Individuation and independent. Next question. If enslaving effect increases with force, what will happen? Or enslaving effect increasing with force suggests which among the following? Options A. Options are option A, mechanical limitation only. Option B, linear muscle behavior. Option C, neural drive scaling across digits. Option D, sensor error. If enslaving effect is seen to be increasing with force, what does that suggest? Options are option A, mechanical limitation only. Option B, linear muscle behavior. Option C, neural drive scaling across digits. Option D, it might be a sensor error. Answer is option C, that is neural drive scaling across the digits. Option C, because the central nervous commands spread across the multiple fingers. That is neural drive scaling across the fingers or digits. Next question. Which condition would most reduce the enslaving effect? Options are option A, increasing force. Option B, isolating intrinsic muscle activation. Option C, using all fingers simultaneously. Option D, increasing wrist flexion. Which condition would most reduce the enslaving effect? Answer is option B, isolating the intrinsic muscle activation. The isolation of or isolating the intrinsic muscle activation will help in reducing the enslaving effect. Answer is option B. The intrinsic muscle allow finer independent control. Next question. A stationarity index close to 0 indicates which among the following? Options are option A, perfect stability. Option B, high unintended motion. Option C, maximum independence. Option D, no neural activity. Stationarity index close to 0 indicates which among the following? The stationarity index close to 0 indicates which among the following? We have already discussed that stationarity means the ability to remain stationary when other fingers moves. So it's close to 0 means the index is almost null. So it means it does not have the ability to remain stationary when other fingers move. So it means high unintended motion. Option B is the correct answer. High unintended motion. Low stationarity index is meaning passive fingers can move unintentionally. Next question. Why is force deficit observed in multi-finger task? Next question. Why is force deficit observed in multi-finger tasks? Options are option A, reduced muscle size. Option B, neural interference between fingers. Option C, tendon rupture. Option D, fatigue. Answer is option B, neural interference between fingers. Because the neural control, when the neural control is shared between the fingers, it reduces the maximal output. That's why a force deficit is observed. Next question: which muscle group contribute most to fine finger control? Which muscle group contributes most to fine finger control? Options are: option A, extrinsic flexors; option B, extrinsic extensors; option C, intrinsic hand muscles; option D, forearm stabilizers. Which muscle group contribute most to fine finger control? Options are: extrinsic flexors; option B, extrinsic extensor; option C, intrinsic muscles; option D, forearm stabilizers. Now here the correct answer is option C, intrinsic hand muscles or intrinsic muscles. Intrinsic muscles are the muscle group that contribute most to the fine finger control. Intrinsic muscles enables precision and individuation. So answer is option C. Next question: if enslaving effect remains unchanged across rest positions, it implies which among the following? Options are: option A, mechanical dominance; option B, neural dominance; option C, measurement error; option D, fatigue, muscle fatigue. What might be the reason if enslaving effect remain unchanged across rest positions? Is it option A, mechanical dominance; option B, neural dominance; or is it a measurement error; or is it due to muscle fatigue? Answer is option B, neural dominance. So if it was mechanical dominance, then rest position change will definitely affect. So because it is neural dominance, the uh, uh, enslaving effect was independent of wrist posture. This is because of the neural control, option B. Next question: which experimental variable is most critical in isolating neural contribution? Options are: option A, force magnitude. Option B, finger length. Option C, wrist posture variation. Option D, skin friction. Which experimental variable is most critical in isolating neural contribution? Options are option A, force magnitude. Option B, finger length. Option C, wrist posture variation. Option D, skin friction. Answer is option C, wrist posture variation. Answer is wrist posture variation. Uh, while changing wrist posture, it changes the mechanics, but the neural connections or neural firing remains unchanged. So it isolates the neural effects. So it was the experimental variable that was most critical in isolating the neural contributions. Next question. In a perfect independent finger system, the enslavement matrix would be options A. Options are option A, fully filled. Option B, diagonal only. Option C, symmetric. Option D, random. In a perfect independent finger system, enslavement matrix would be which among the following? Options are option A, fully filled. Option B, diagonal only. Option C, symmetric. Option D, random. The answer is option B, that is diagonal only. So in a perfect or independent finger system, the enslavement should not happen. So like it will only uh, activates the finger which is intended to move. So only active finger produces the force, no other fingers. So the other diagonals, other elements other than the diagonal times becomes 0 and it becomes a diagonal matrix. The answer is option B, diagonal matrix, because only the active finger produces the force and active fingers will be in the diagonal direction. Next question. What does a non-zero off-diagonal element in an enslavement matrix indicate? Options are option A, noise. Option B, finger strength. Option C, interfinger coupling. Option D, fatigue. What does a non-zero off-diagonal element in an enslavement matrix indicate? Yes, correct answer. Option C, interfinger coupling. So a non-zero off-diagonal element shows a chance of enslavement. It gives the value of enslavement in the enslavement matrix. The answer is option C. It represents the unintended force, unintended force created in other fingers due to the active finger. Next question. Why thumb is often excluded in such studies? Options are option A, it is weaker. Option B, it has unique biomechanics. Option C, it lacks tendons. Option D, it is immobile. Why thumb is often excluded in such studies? Answer is option B. It has unique biomechanics. Thumb is uh, anatomically very different from the other fingers. So, and it has its own control mechanisms. So, uh, thumb is often excluded from such studies. Option is option B. It has unique biomechanics due to its anatomy and dedicated control mechanisms. Next question: which scenario would increase force deficit? Which scenario would increase a force deficit? Options are option A, single finger pressing. Option B, simultaneous multi-finger pressing. Option C, passive movement. Option D, wrist neutral. Which scenario would increase force deficit? Option A, single finger pressing. Option B, simultaneous multi-finger pressing. Option C, passive movement. Option D, wrist neutral. Answer is option B, simultaneous multi-finger pressing, because by doing multi-finger pressing, the neural sharing reduces the total force output. Option B. Next question. Which index directly measures unintended force production? Options are option A, stationarity index. Option B, individuation index. Option C, enslavement index. Option D, flexibility index. answer is correct. Correct answer is option C, enslavement index. Enslavement index directly measures the unintended force production. It quantifies the force spillover. Or next question. What is the main limitation of mechanical coupling explanation? What is the main limitation of mechanical coupling explanation? Options are option A, it ignores tendon effects. Option B, it cannot explain posture independence. Option C, it overestimates force. Option D, it lacks experimental support. What is the main limitation of mechanical coupling explanation? Options are option A, it ignores tendon effects. Option B, it cannot explain posture independence. Option C, it overestimates force. Option D, it lacks experimental support. We will be winding by two more questions or one more question. This and one more. Answer is option B. It cannot explain posture independence. What is the main limitation of mechanical coupling? Mechanical coupling, if we take mechanical coupling as the hypothesis, then the mechanical coupling changes with respect to rest posture, but the independence of rest posture limits the mechanical coupling theory. Next question, or last question. Why do intrinsic muscles show less enslaving effect? Options are option A, smaller size. Option B, shorter tendons. Option C, no neural control. Option D, less activation. Why do intrinsic muscles show less enslaving effect? Answer is option B, shorter tendons. Because intrinsic muscles have shorter tendons, it reduces the mechanical coupling. So answer is correct answer is option B. So that's all for today. Thank you for joining. Thank you for joining.